Today we're going to be going through the honors question for the study guide. The honors question for the study guide, so honors Algebra 2 students only. Over here I have a diagram of a circuit. Okay? This symbol represents a resistor that will always be a real number. So resistors will always be in the form of a real number. Alright, so it will be a real number. Okay? If it's a squiggly line, it will be an imaginary number that is positive. An imaginary number that is positive. So that is an inductor, and its impedance will be an imaginary number that's positive. And the double lines represent a capacitor, who will be an imaginary number that is negative. So on your circuit, the impedances are represented with the symbol of ohms. So that symbol is called an ohm. Okay, so that's a positive measure of impedance, and then we need to rewrite it as its complex number. So if I want to find the impedance of each individual component, then I start by going through in my resistor. I'll take the 6, and then since it's a real number, I just leave it. It's just the real number 6. So if it has an impedance of 6 ohms, then its impedance is measured by 6. Okay, then the inductor is on the side there. And an inductor is an imaginary positive real number. So since it's 4 ohms, I say it's 4I. And down here, that's my capacitor. And so the capacitor has to be a negative imaginary number. So it says 2 ohms there, but so that's actually going to be a negative. It's going to be working against these other guys. And so it's negative 2I. To find your total impedance, you add each individual impedance together. To find your total impedance, you're going to add each individual impedance together. So you're going to get 6 plus 4I minus 2I. We can combine like terms only. They're only like terms if they both have I. So only these two on the right can combine. And 4I minus 2I is going to become 2I. So I get 6 plus 2I is my total impedance. Okay, so now let's look at the voltage situation. Let's look at the voltage situation. So the first question before we talk about voltage is, what is Ohm's law? And Ohm's law is V equals I times Z, which means our voltage is our current times our impedance. Okay, so you have to do voltage times is current times impedance. Current times impedance. So I want to find the total voltage. And so there are going to be two ways to go about this. So the first way I'm going to show you is with individual voltages. The first way I will do it is with individual voltages. And then afterwards I will show you a second way you can do it. So if I do it with an individual voltage, then I'm going to start with my resistor. And I'm going to take this current of 18 minus 6I, and I'm going to multiply it by the impedance of the resistor. And so the impedance of the resistor was 6. And so now I'm going to distribute that 6, and I'm going to get 6 times 18. Let's see, 18 times 6, that's 8. That's 108. And then I get 6 times negative 6I is minus 36I. Okay, so that's the voltage of just the resistor. Then I'm going to find the voltage of the inductor. So I take the same current, because the current doesn't change. I take that same current, and now I'm going to multiply it by 4I, the impedance of the inductor. So I get 4I times 18. So 18 times 4 is 72, so I'm going to get 72I And then negative 6i times 4i is negative 24i squared. But remember, I squared is negative 1. So that's really positive 24 plus 72i. And then I'm going to take my capacitor and I'm going to take the same current, I'm going to multiply it by the impedance of the capacitor, negative 2i. So I get negative 36i, and then a negative times a negative is a positive 12. I times I is I squared. But remember, I squared is negative 1. So this becomes negative 12 minus 36i. These are the individual voltages, not the total voltage. To find the total voltage, you're going to add them all together. Remember, when we add together complex numbers, we're going to add all the real portions. So I'm going to add the 108, 24, and negative 12 together. And then separately, you add the imaginary, the negative 36 plus 72 minus 36. All right. So my total voltage is going to be 108 plus 24 minus 12. And to that, I'm going to have negative 36i plus 72i minus 36i. So when I add these together over here, I get 120. And when I add these together here, I get 0 i's. So my total voltage is 120 volts. 120 volts, which does match our AC power source, Do not try to just write this as a final answer. You need to show how you get to these values. Okay, because if it's a circuit for a different country, the voltage may not be 120. All right, now I'm going to show you the second way. So if you're fine with this method, go ahead and stop. But I do want to show you one more way. So impedance, these were individual impedances times the same current. I could go ahead and rather than doing individual impedances, I could take my total impedance times the current. So I'm going to take my total impedance times the current. So I'm going to take my current of 18 minus 6i, so that's my current, and I'm going to do it times my total impedance that we found earlier. My total impedance was 6 plus 2i. So now I have a binomial times a binomial, so I'm going to use the distributive property. I'm going to take 18, I'm going to distribute it once. So 18 times 6 is 108. And distribute it again. 18 times 2i is positive 36i. Then I'm going to take the second term and distribute it twice. And so I'm going to go negative 36i and negative 12i squared. Negative 12i squared. Now I'm going to combine like terms. I get 108. 36i minus 36i are like terms. They become 0. And minus 12i squared, well, that becomes negative 12 times negative 1. Two negatives become a positive. And so 108 plus 12 is 120 volts. So notice both methods get us to the same result.